Okay, let's start with a review of the three states of matter. Who can tell me what are the three states of matter? JD, give me one.
Solid.
All right, Sarah, give me one.
Liquid.
Caroline, give me one. Solid, liquid, and
Gas.
gas. The three states of matter are solid, liquid, and a gas. Who can tell me about a solid? Keely, what do you know about solid?
That the molecules don't have that much energy and they are really close together.
The molecules don't have that much energy and they are really close together. I love it. Who can tell me about a liquid? Tyler.
The molecules are moving like medium and they bump into each other.
Right, the molecules are moving at a speed that's just right. Keely, you got something to add?
And solid, it has a definite volume.
Solid has a definite volume. What about the liquid? Jacob Harris, what about its volume? I think that you're on the right track, though. Who can tell me about the shape or the volume of a liquid? Brady.
Like if it was in a water bottle, it would be the shape of a water bottle. If it was the shape of a water gun, it would be the shape of a water gun.
That's right. It takes the shape of whatever container that it's in. It doesn't have a definite shape. All right, and then Jake Pierce, you said you were waiting to tell me about a gas. So tell me about a gas. Speak loud, though, so that we can hear you, okay? All right, he wants to take a pass on that. Sierra, tell me about a gas. Class.
Yes.
I'm gonna wait for you. You're right. You cannot measure how much space a gas takes up. Let's see. Who haven't I heard from today? Jalen.
The molecules are moving really fast because they have more energy.
The molecules are moving really, really fast because they have more energy. I love that keyword of energy, Jalen. And JD, did you have something you wanted to add?
In gas, it has no definite volume.
That's right. Someone else kind of was leading up to that, but I love that you asked that. No definite shape.
Like this is dissolved away, but gas, like it dissolves away sooner than water.
Yes, that's faster. So gas is matter that has no definite shape and takes up no definite amount of space. Put your hands up for just 1 second and I'll come back to you, okay? A liquid has a definite volume, but it takes the shape of the container.
It's in.
That's right. So there is a definite amount of liquid there,
It's
but the shape depends on what it's in.
It turns into a different shape and everything. It looks like it don't have that much, but it actually does.
Depending on the container. And then a solid has a definite shape and a definite volume. Now the other day we talked about buoyancy. Who can tell me what I told you to remember about buoyancy? Janaea? I love that you use your words to get some help. Caroline, what do you know about buoyancy? It floats. It's what makes a boat float. Everyone say it with me. Buoyancy.
Buoyancy
Is what makes a boat float.
is what makes a boat float.
Okay, and what are the two factors that we talked about that's going to determine whether or not something floats or sinks? Jalen.
Volume and mass.
Volume and mass. How heavy it is and how much space it takes up. Who can tell me what did we do with that ball of Play-Doh?
Ooh.
Stephanie.
We turned it into a bowl and it floated, and then we turned it into a ball and then it sunk.
That's right. So we took a ball of Play-Doh and we had Tyler make it into a boat, right? And I put it in the water and you all saw that Play-Doh floated. But then whenever I took that same Play-Doh out and I wrote it into a ball, it sunk. Because the volume changed.
It ain't hollow in the middle like it was out in the boat.
It wasn't hollow in the middle. So when it was a boat, the volume was larger. It took up more space.
It had hollow, so it floated.
and when you rolled it up, it did not have all those, so it got heavier on its own.
Right. And so, what was our one key word that Miss Lisa tells us every day that we need to talk about?
Energy.
Everyone say it with me.
Energy.
All right.
Can we watch it?
Yay.
A mixture is when the sugar and the water are together. We're not going to be able to take them back apart. Okay?
The sugar will disappear.
The sugar should dissolve in the water, exactly. So we can't separate those parts back apart.
So, what's this vocab word called again?
So underline solution in your vocabulary. And then there's an example next to it, and it says sugar and water. Okay? Underline those two words so that you remember that those two, when we mix them together, we can't separate them back apart.
Find me a snap.
And you also need to know a word that's not on your vocabulary list. Okay? Because you really need to know what is the opposite of a solution. And the opposite of a solution is called a mixture. Okay? A mixture, when you mix it together, you can still see the individual parts. Okay? So, I'm going to show you an example. We're actually going to make some trail mix today.
Hey.
When we make trail mix, can you see the individual parts?
Yes.
Yes. They do not dissolve together, do they?
No.
You can see the pretzel. You can see the Cheerio. You can see the peanut. Okay? You can see those things. So they don't dissolve into each other. Okay? So we're going to do that today. So what I need you to do on your desk, going through, notice you have on your desk pretzels. You have peanuts.
Yeah.
You have Cheerios. And now Miss Duke is bringing around raisins. So our mixture is going to have 4 parts. What I'd like for you to start doing on your desk is mixing those together.
If that was like
I have people talking about it and down to the raisins. So we have dissolved our Kool-Aid and our sugar into our what? Water. Now we have a solution. Repeat after me. Solution.
Solution.
We cannot take it back apart now. Okay? We can't. It's not like our mixture where we can go and we can pick up a pretzel stick. Okay? We can't go into our Kool-Aid and pick out a piece of sugar or pick out a piece of Kool-Aid or pick out a piece of water. We're not able to do that. It is a solution. Okay?
So then, Sierra, how do you know that your trail mix is a mixture and not a solution?
You can pick the stuff out of it.
You can pick your stuff piece by piece back out. You can still go in there and find a pretzel, still go in there and find a raisin. Dante, how do you know that the Kool-Aid is a solution, not a mixture? Because you can't what? I can't take the Kool-Aid back out, right? I can't remove it back from that water. Once it's in there for good. I can't take it back apart no matter what I do. All right, let's talk about chemical and physical changes. A chemical change is when there's a reaction with something and a new substance is formed. Now, a physical change is just a change in the state of matter, the change of the way something looks. Maybe the change of the size or the shape or the color. Now, some things that could cause a chemical change would be like heat. Heat usually causes some type of a chemical change. And you might also notice that a chemical changes happen because it could have a smell, like in sour milk. So tell me, Cody, if I slice an apple, if I just cut it up, is that a chemical change or a physical change?
Physical.
It is a physical change. You're exactly right, because it's still the same apple. I just changed the shape of it.
And I learned from the best.
All right, Mason, tell me.
This stuff certainly smells good.
Tell me. Sour milk. Is that a chemical change or a physical change? Chemical change, because the way the milk is made is completely different. What about an ice cube that's melting? Is that physical or chemical? Physical change.
Because I think you could still take it, then you could put it in the freezer, then it turns to the ice cube again.
It turns to the ice cube again. Perfect.